Part 2, we're going to look at some logistic models. Now, you, of course, will need a calculator for this. A logistics model, right here, relates the proportion of U.S. households that own an Ewok to the year. So let t equals 0 represent 2008, and 1 year later, it's 2009, and so on. The question says, what proportion of the U.S. households own an Ewok in 2008? So in 2008, we know that that's 0. So we're looking for P of 0. So if I plug that in, we go 0.9 over 1 plus 1 plus 6, E. And if I plug in 0 here, we get E to the 0. So we get 0.9 over, that just becomes 7. And we can type that in the calculator here. We get clear that out, 0.9 divided by 7. And we get 0.129, which is about 12.9% of the population owned an Ewok in 2008. To find the maximum proportion the household will own an Ewok, we're going to do a little bit of calculus. It's called a limit, okay? And we're going to say the limit as time gets really large, as we say go to infinity. Now in calculus, we say this is the limit as t goes to infinity of our function. Now in calculus, we're going to take a look at some ways to solve this. But for right now, what we're going to do is we're going to let p become a really large number. Just type in like a number, 10,000. So let's talk 10,000 years from now in the future. And I'm just going to type that in. This becomes 0.9. 0.9 over 1 plus 6 e to the negative 0.32 times 10,000. And we're going to type that in our calculator. 0.9 divided by 1 plus 6 e to the negative 0.32 times 10,000. And I hit enter, and what do I get? 0.9. So what that means is even if I go 10,000 years into the future, let's even do 1,000,000 years, just change this to another 0, 2 more zeros, it's still 0.9. So not everybody will ever own an Ewok, because some people don't believe in owning Ewoks, that they should run the Forest of Endor free. So this is roughly about 90%. Matter of fact, the 0.9 is a limiting factor. We actually call that a limiting capacity. That 0.9, it's always going to be that top number right there. When will 0.8 or 80% of the households own an Ewok? Well, that's easy. This is now going to be P. So if I plug that into the formula, 0.8 equals 0.9 over 1 plus 6 e to the negative 0.32 t. Now, a little bit harder to solve, so just be careful. One of the best ways I know to solve this one is to use your calculator. Since we're using our calculator, might as well. We'll call this y1. Plug this in for y2 and find the intersection. Since we're using a calculator, have fun with it. So in my calculator, let's take a look here. Clear. Go to y equals, nothing in there. So I go 0.8. On the bottom, I'm going to go 0.9. Now, when you type something in your calculator, cover your bottoms, divided by 1 plus 6 e to the negative 0.32 x, and I think that's it. Close it twice, and I'm going to graph it. I don't really care what the graph looks like. All I really want to know is where do they meet. Oh, wow. I might have to go a little bit further. So I'm going to change my window here. Maybe go with my y max from 0 to maybe, let's say 1, because I only want to go to 0.9 anyways, but I might change this a little bit. Okay, might change this. Let's go 50 years from the future and see what happens. There's my 0.8. There it crosses, and that's what I'm looking for. See, we can see the limiting capacity. There's our 0.9 right there. Okay, that's my limiting capacity, but I want to find out where they meet. Second calc, go to 5, intersect, enter. Just type in first curve, enter. Second, enter. Scroll to where you think. Enter. Looks like they meet right here. I hit enter, and we get t equals roughly 12.098. What's that going to be? Years. So now, what year will that be? Well, we started in 2008, add the 12, and we get 2020. So in the year 2020, roughly 80% of the U.S. will own an Ewok. All right. The next example is a calculator model. This is very easy. This is our regression. Now, we've done regressions before, but it's been a while. Each year after she bought her new car, Martha Jones kept track of the market value of the car. We want to find an exponential model. So what we're going to do, this is going to go to our list. We're going to make a list. So I go stat, edit. So it goes stat, edit, and I'm going to type in L1, that's going to be my years. L2, that's going to be the market value of the car. So L1 is going to be 1, 2, 3, 4, 5, 6. How much will it be worth? L2 is going to be the value. 25,000, 20,000. Whoa, that's not looking 20,000, 16,000, 12,800, 10,240, and 8,192. Second quit, just like school. That's going to enter. That enters into the lists. To solve it, we're going to go again to stat. So press your stat buttons right down here. You can go to calc this time. And you want to go down to, we're looking for an exponential regression. EXP reg. I scroll down until I find it. Linear, oh look, natural log, that's your logarithmic. Exponential regression, right there. Hit enter. And if you clear out your memory, all you got to do is hit enter one more time, and it'll give you your equation. So it will be y equals A. They're telling me A is 57,745.31. There's A times B, which is 0.749 to the x. Yuck. And there's our regression model. Okay? So, just make sure, and just make sure we can go stat, calc, exponential regression, and you can go like second L1, comma L2, and that's going to put them in the right order. And you get the same thing. Okay? Predict the value of the car when it's 10 years old. So, well, we use X, although we should call that T. So T is 10, and what I'm going to do is I'm going to type all this in. Y of 10 equals 57,745.31 times 0.749 to the 10th. And I just type all that in. 57,745.31 times 0.749 to the 10th. And it says it should be worth about $3,208.74. Estimate the amount that she paid for her car. Well, that's where t equals 0. So I just do this, y of 0. 57,745 times 0.749 to the 0. Well, that just becomes 1, and what's the price? $57,745. All right, so thank you, and don't forget, we do have a test on Tuesday, so if you need to start looking over this material, go ahead and do so.